So this next video we're talking about something called the empirical rule. The empirical rule gets another name. Sometimes the empirical rule is called the 68, 95, 99.7 rule, and we'll see why in a second. And it describes the normal probability distribution, specifically the breakdown of probability within each standard deviation of the normal curve. So, what the empirical rule tells us is that within one standard deviation of the mean, we expect about 68% of the data. So more than half the people in a normally distributed probability set should sit within one standard deviation below the mean and one standard deviation above. We expect 95% to sit within 2 standard deviations of the mean. That's almost everyone. 2 standard deviations out, almost everybody. And then 3 standard deviations is essentially everybody. The 3 standard deviations is our 99.7% of all data. Meaning we expect almost nobody, less than 0.5%, to be way out in those tails. So in a normal distribution, more than half of everybody's in the middle, and then we get a little bit more as we move out, and out past 3 there's hardly anybody. The question is, why do we need to know this? We know that there's calculators that can do this math for us. And the answer is the empirical rule helps us estimate probabilities quickly for situations where I can do it without a calculator, which is nice. But it also helps me check the answers my calculator spits out. If I know what the curve looks like and I have an accurately drawn picture, I can make a guesstimate of my answer before I do the math and check that what's coming out of my calculator makes sense in terms of the problem. So really the power of the empirical rule in modern day math with computers and calculators is it's a BS detector. It's going to tell us when we made a calculator error. We're going to do some examples estimating just to get some practice working with it. Before I do that, I'd like to do some more breakdowns on this curve just for ease of use. So one thing we learned in our first video is we know this curve is symmetric. So I know that half of my data should be at or above the mean, and that half of my data should be at or below the mean. That's helpful. And then I can do some smaller breakdowns. So if I know that this is 68%, this should be half of 68, which is 34. So this is 34, and this is 34. For the next chunks, I have to do a little bit of thinking, because I know that these areas here are going to be 95 minus 68. And then I'm going to cut it in half. So 95 minus 68, and then I divide that by 2. So these chunks here are 13.5% each in each of those wedges. And we're going to do the same idea for these chunks here. I know they're going to be 99.7 minus 95, and then cut in half. And we get 2.35. All right, let's go ahead and do some examples using the empirical rule. So the example says the height of adult men in the United States is approximately normal with a mean of 70 inches and a standard deviation of 3. What percent of adult men in the US are shorter than 67 inches, 5'7"? So I'm going to come in here in orange and label those hash marks in our picture above. So I know the mean is 70, and my standard deviation is 3. Those hash marks are counting by 3. So 73, 76, 79, 67, 64, 61, assuming I can subtract 3 in my head at this time of day. And this problem is asking what percent of adult men are shorter than 67. So here is 67. And notice it's outside of that 68. I want this area here. So what I want is I want 100 minus 68. I want to remove that chunk, and then I want to cut it in half. So 100 minus 68 is 32. So there's 32% in both of these tails. 68 in the middle. And then I'm going to cut it in half because I just want the less than 67 part. And half of 32 is 16. So I know that 16% of adult men in the US are shorter than 5'7". So the next one says, what percent of adult men in the US are taller than 76 inches? So similar idea, 76 is here, it's at the 2 standard deviation marker. So I know that 95% is here. I want outside because I want greater than. So I'm going to do that trick. I'm going to subtract 95 from 1, and I know that's going to give me 5%. And then that 5% gets split between these two tails because the curve is symmetric. So this tail is half of 5%, and without a calculator, I know that that is 2.5%. Last question is a little less tricky. It says middle 68% of heights of the US adult men lie between which two values? And we go up to our picture, we look for middle 68%. That's within 1 standard deviation, and I can see that's between 67 and 73. So that's basically how we use the empirical rule to help estimate values and check what's coming out of our calculator. You'll notice we had a picture that was already drawn and labeled. As we move throughout this week, you're going to notice me drawing these curves and labeling them for basically every problem we do. It's a really good habit to get into because we're going to need those when we start doing inference in week 4. All right, if you have any questions, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.